problem number 7, which is 2753. A very interesting problem. Here is 6 ohm. I call this point P. Here is 3 ohm. I will delete the word ohm, the symbol ohm. This is 3 ohm. Switch S continues here. 3 ohm. 6 ohm. This point connected to a battery. Plus, minus 36 volts all the way back to point P. And that's the circuit. And as we start, S is open. And you are being asked, what is the potential difference between this point A and this point B? If the switch is open, there's no current flowing through here. There is 36 volts over here. There is 9 ohm here in series. So Ohm's law immediately tells me that the current through here is 4 amperes. Here there's also 9 ohm. So also the current through both these two, I, is also 4 amperes. And no current through here. What is Vp minus Va? Vp minus Va. P is a higher potential than A. 4 amperes, 6 ohm. So that is plus 24 volts. What is Vp minus Vb? Vp minus Vb. This has a higher potential than this. 3 ohms, 4 amperes, that is plus 12 volts. So if you want to know the potentials, this is 36. This jump is 24, so that leaves this with 12. 0 here. This jump is 12, so that leaves this with plus 24. And this jump is 0. So here you see the 4 potentials at these 4 positions. And so it's immediately obvious that Va minus Vb equals 12 minus 24 equals minus 12 volts. So therefore, if you throw this switch, clearly there's going to be a current going through here. That is inevitable. And that's exactly what we are going to do. We're going to close the switch and we want to know what is the current through that horizontal section. Now, I will make a slightly different drawing. Not because there was anything wrong with the previous one, but I just feel like making a different drawing. I don't want to get bored. So, when you don't want to get bored, you do something different. This is that point P. This is that point A. This is the point B. Circuit, no change, it's 3 ohms. Here, 6 ohms. This point is going back 36 volt battery to this point. And you will convince yourself that this circuit is completely identical. Now, let current I go through in here. And let the current split here between I1 and I2. So I always know that I equals I1 plus I2. I make now the assumption, which could be wrong, that there's also a current flowing in this direction, which I call I3. If I find I3 later to be negative, no sweat, it means that the current is flowing in the opposite direction. So that's no problem. When I come to this point here, if I2 is coming in and I3 is going out, oh, excuse me, forgive me, I call this I2 and I call this I1. And I realize that it makes no difference, but since that's the way I have made my notations, I would like to stick to that. So I call this I1 and I call this I2. So I2 comes in, I3 comes out, so then there's only one way, that upwards must go I1 minus I3. And if this number I1 minus I3 is positive, then indeed there will be a current in this direction. If it is negative, then there will be a current going in this direction. Now we come to this point A. I2 is coming in, I1 is coming in, and I3 negative. So therefore I have here minus I3. So that's the current through this resistor. But now watch at this point. I1 plus I2 minus I3 plus I3. So what comes out here is I1 plus I2, which is exactly I, and so my symbols are internally completely consistent. And so what I have to find now is I have to find 3 equations, Craig, with 3 unknowns. I want to know what I1 is, what I2 is, and what I3 is. And then I, of course, also know I, because I know that I is I1 plus I2 plus I3. And so I have to apply Kirchhoff's law 3 times in an independent fashion so that I can get, in a relatively quick way, I1, I2, and I3. All right, where do we start? And in what direction are we going to march? I suggest that we start here. And I suggest that we're going in this direction, counterclockwise. And I suggest that our first journey, you could of course choose any other journey, but I suggest that our first journey is going to be all the way through the top and back. All the way through the top and back. Ready for that? Uphill. I'm going to make a little easy table. E1, I1, I2, and I3. I go uphill 36 volts, so I have here plus 36. I go downhill 6 times I2, so I get a minus 6 here. You must multiply that by I2. I go downhill 3 I1 minus 3. Downhill 3 I2 minus 3. Uphill 3 I3, therefore plus 3. Because remember, this is a minus sign. And I come out here, and I'm finished. This is 0. What now is my second loop going to be? Well, take your pick. I have decided to take the lower one. I could have picked another one, but I'm going to take the lower one. You ready for the lower one? 36. I go through here. I go down 3 I1 minus 3. I come here, I go down in potential 6 I3 minus 6. Now there's a 0 here. Ha! There is no I2. And that equals 0. Now I have to choose a third loop. And for my third loop, watch me carefully. I could pick this one, I could pick this one, I could have picked this one, but I'm going to pick this one. Through here, up here, down here, this way, and back here. Why not? I can choose any one I want to. Why not doing that one? 36, that's this one, minus 6 I2. Now, careful, I1 is coming towards me. That means I'm going up in potential because of I1. So that is plus 3. But it's going to be minus 3 for I3. So now I'm here. I'm going down 6 I3, so I have another minus 6 here. And I come out here, and this equals 0. Well, 3 equations with 3 unknowns. You have to multiply them, of course. So this is 36 minus 3 I1 minus 9 I2 plus 3 I3 equals 0, and you can solve these three equations with three unknowns. I have a little bit extra time, and I will help you a little, although I'm not going to solve them for you. I'm going to divide them all by 3, so I will get 12 minus 1 minus 3 plus 1, 0, 12 minus 1, 0, minus 2, 0, 12 plus 1 minus 2 minus 3, 0. I call this equation 1, equation 2, and equation 3. And what is interesting, that if you subtract 1 from 2, so 2 minus 1, if you subtract this one from this one, you find immediately that I2 equals I3. And that's not so obvious. And when I found that, I said to myself, maybe there is a faster way to see that. And so I went back to this diagram and I looked, why is there any obvious reasons why this current here is the same as this current here? Well, there is a lot of symmetry. This is a 6, this is a 6, this is a 3, this is a 3, but then there is a 3 here. I'll be very frank with you, I could not find an obvious reason why I2 is I3. If you do, I would be very obliged and very grateful if you give me a call and you let me know. In any case, you can massage these three equations, and I think I found that I1 is something like 5.14 amperes, and I think I find I2 equals I3 equals 3.43 amperes. Three equations with three unknowns you have to solve. Now you have to know what is the current through IS. That, of course, is I1 minus I3. And if this turns to be positive, turns out, then the current is indeed going up. And it is indeed going up because you find that it is 1.71 amperes. And so the current through that resistor 3 is indeed in the upwards direction.